Statistics. This is the empirical rule. So this is 1 standard deviation from the mean, this is 2 standard deviations from the mean, and this is 3 standard deviations from the mean. 1 standard deviation from the mean is 68% of the data, 2 standard deviations is 95%, and 3 standard deviations is 99.7%. Let's look at an example. In a university lecture class with 174 students, the final exam scores have a mean of 68.5 and a standard deviation of 7.3. The grades on the exams are all whole numbers, and the grade pattern follows a normal curve. Find the number of students who receive grades from 1 to 2 standard deviations from the mean. So 2 standard deviations from above the mean is 47.5% of the data. So if we multiply 0.475 by the total number of students, we get 82.65, and we should round down since we can't have half a student, and we get 82 students. This is our second example. Find the number of students who receive grades below 60. So as you can see, the mean is 65 with a standard deviation of 5. So below 60 is 13.5% plus 2.35 plus 0.15, which equals 16%. And you multiply 0.16 times 174, which is the total number of students, and we get 27.84, and we get 28 students who receive grades of 60 or below. So on the calculator, to calculate normal distribution probabilities with the calculator, on the calculator go to second vars and to normal CDF. And let's look at so there's lower boundary, upper boundary, mean, and standard deviation. So let's look at our first example. These are the heights of the men ages 25 to 34. The standard deviation is 2 with a mean of 70. So 1% of men are 69 to 71 inches tall. So here we put the lower bound as 69, the upper bound is 71, the mean as 70, and the standard deviation as 2, and we get 38.3%. Okay, let's look at the second example. Find the percent of men between 65 to 74. So on lower bound you type in 65, on upper bound we go to 74, and we have the mean as 70 and the standard deviation as 2, and we get 97.97, which is 97.1%. Okay, so suppose a survey included 100 men. How many would fall below 75 inches? So we'll go to normal CDF again. So the lower bound would be 0. The upper bound would be 75. The mean would stay as 70, and the standard deviation would stay as 2. And we would get 0.9937, and then we multiply that by 100 since there's 100 people, and we get 99.37, which is 99 people. Calculate the boundary points using percent and area of the group. On the calculator, go to second vars and inverse norm. There would be area, the mean, and the standard deviation. Let's go to the first example. The score on the Algebra 2 test have a mean of 76.4 and a standard deviation of 11.4. Mr. Reeves made it so only 5% of the students can get an A. What is the minimum score you can make to get an A? So, since only 5% can make it, the area would be 0.95. The mean would be 76.4. and the standard deviation is 11.4, and you would get 95.15. So the minimum score to get an A is 95.15%. Now let's go to the second example. A mean height of the American woman is 69 inches with a standard deviation of 2.4 inches. If Cynthia is in the 21st percentile, how tall is she? So
Right here?
the area would be 0.21. The mean height is 69 and the standard deviation is 2.4. And she would be 67.1 inches tall. The z-score tells you how many standard deviations a value is from the mean. To find it, you have the value and then you subtract it from the mean and then over the standard deviation. So let's look at the first example. A set of values has a mean of 85 and a standard deviation of 6. Find the z-score of the value 76. So you do 76 minus 85 and the standard deviation of 6, which equals negative 9 over 6, which is negative 1.5. So the z-score is negative 1.5 standard deviations from the mean. Now let's look at another example. A set of values with the mean of 62 and a standard deviation of 5.7 is normally distributed. Find how many standard deviations from the mean a given value is. So the first value is 67. So we do 67 minus 62, which is the mean, over the standard deviation, and then we get a positive 0.88. The next one is 73, so we do 73 minus 62 and over the standard deviation, and we get a positive 1.93. And then for the last one, we have the value of 59, so we do 59 minus 62 over 5.7, and we get a negative 0.53.
Types of sampling. Simple random sampling is that all have the same probability. For example, putting all names in a basket and then drawing a random name. Stratified sampling is when you highlight specific subgroups. For example, you split the population into groups and then you take random specific samples from a group. Cluster is when you take specific types of people in a group. For example, you split into groups and then you take samples from the entire group. Voluntary response is when they select themselves. They can respond or not to their own treatment. Systematic sampling is where there's some system in the sampling. For example, you choose every third person or every other person or every 100th person who enters a room. Convenient is taken from a group that is conveniently accessible. The teacher picks every fifth student that walks into a room to answer the questions. What type of sampling is this? This is systematic because the teacher has a system in picking the responders. Mr. Mack picks 5 sophomores to take a survey out of freshman, junior, senior, and the sophomore group. What type of sampling is this? This is stratified because he picks specific, well, not really specific, but certain students from the sophomore group out of different groups.
Let's now look at the types of bias. The first is undercoverage bias. Members of the population are inadequately represented by the sample. Non-response bias. Individuals chosen are unable to participate in a survey. Question wording bias. Wording can be misleading. There cannot be any hidden messages. Response bias. People give false or misleading answers. Voluntary response bias. Sample members are self-selected volunteers. Let's look at one example. A poll sponsored by the disposable diaper industry asked, it is estimated that disposable diapers account for less than 2% of the trash in today's landfills. In contrast, Beverage containers in third-class mail and yard waste are estimated to account for about 21% of the trash. Given this, would it be fair to ban disposable diapers? So what type of bias is it? It's question wording bias. Now let's look at another example. A survey was given to viewers of a show to fill out online. This would be voluntary response bias. A survey about basketball versus soccer was given to people watching a soccer game. This would be undercoverage bias.
Experimental versus observational investigations. Experimental. Investigators apply treatment to experimental units and then observe the effects. Observational. Investigator just observes and measures variables without treatment or changing. The only treatment is controlled by the question itself. Some people who race wolves give them large doses of vitamin B and believe they would run faster. Investigators tried 3 different diets on 6 wolves. They found that dogs who took in vitamin B ran faster. What is this? This is experimental because the investigators apply treatments to the dogs. You try. Among a group of students of women aged 55 and older, they were tracked for years. Investigators found out those who didn't smoke and those who did had a major health difference. Is this observational or experimental? This is observational because the investigators didn't apply anything to the woman. Parameter and statistics. Parameter describes the entire population. Statistics describe the sample. Population and sample. Population includes all objects of interest. Sample is a portion of the population. For example, of all high school teachers, 96% say that algebra is essential. This would be parameter because it describes the entire population of high school teachers. You try. Of 500 high school teachers, 75% say that algebra is essential. This is statistic because it describes a sample of 500 high school teachers. Expected value. A probability distribution provides the possible outcomes of a random variable and their corresponding variables. An expected value is the weighted average of the possible outcomes of a random variable. Example. You pay $10 to play the following game of chance. There is a bag containing 12 balls. 5 are red, 3 are green, and the rest are yellow. You are to draw one ball from the bag. You win $14 if you draw a red ball and $12 if you draw a yellow ball. The possibility of you drawing a red ball is 5 out of 12. The possibility of you drawing a green ball, which earns you 0, is 1/4 of a chance, and the possibility of you drawing a yellow ball is 1/3, where you earn $12. So here you multiply the money and the probability together, and then you add each of the ball types together to get $9.83.
Games. A game is a fair game when the cost of each game equals the expected value. A casino game costs $3.50 to play. You draw one card from a deck. If it's a heart, you win $10. If it's a queen of hearts, you win $50. Is this a fair game? There's a 12 over 52 chance of drawing a heart, a 1 over 52 chance of drawing a queen of hearts, and a 39 over 52 chance of drawing anything else. So we multiply the amount of money you get times the probability, and then we get it to equal $3.26. The game isn't a fair game because you pay $3.50 to play a game and win only $3.26.